In the vastness of space, beyond the familiar planets of our solar system, lies a staggering number of distant worlds, exoplanets, orbiting stars hundreds or even thousands of light years away. Among them is a system that has intrigued astronomers since its discovery: Kepler-277, home to two of the largest rocky planets ever found. One of those planets, Kepler-277b, defies expectations. With a mass and density far beyond any terrestrial planet we know, it challenges our understanding of planetary formation and evolution. Could such a world support life? Or is it a massive, uninhabitable furnace? This episode explores what we currently know about Kepler-277, its planetary giants, their star, and the tantalizing but challenging question of whether these worlds could host any form of life. From telescope data to theoretical models, we dive deep into the science behind one of the most extreme planetary systems discovered so far. Kepler-277 was discovered by NASA's Kepler Space Telescope, a groundbreaking mission launched in 2009 to hunt for exoplanets using the transit method, observing tiny dips in a star's brightness caused by a planet passing in front of it. Over its years of operation, Kepler detected thousands of planetary candidates, including some truly remarkable finds. One of them was a star now cataloged as Kepler-277, located roughly 1,500 light-years away in the constellation Cygnus. The transit signals revealed two planets, later named Kepler-277b and Kepler-277c, orbiting the star with astonishing regularity and surprising mass. Their light curves and subsequent analysis suggested a system with super-Earths, or more accurately, mega-Earths, rocky planets significantly more massive than Earth. But as more data rolled in, one thing became clear: Kepler-277b wasn't just massive. It was denser than any planet of its size had a right to be. Kepler-277b is one of the largest rocky planets ever discovered. It has a radius about 2.92 times that of Earth, but its mass is estimated to be an incredible 87 times Earth's mass. For comparison, Earth itself is just 81 times the mass of our Moon. Despite being nearly 3 times Earth's size, Kepler-277b's mass is far more than expected for a rocky planet. This means it has an extremely high density, higher than any rocky planet we know of, including Earth and even Mercury, which is the densest planet in our solar system. Such a high density suggests an iron-rich composition, possibly with an enormous metallic core surrounded by a relatively thin silicate mantle. In fact, the core could make up more than 70% of the planet's total mass, making it a true planetary heavyweight. But this immense gravity comes at a cost. The surface pressure would be crushing. If you could stand on Kepler-277b, which is unlikely, you'd be pulled down by a gravitational force nearly 6 to 7 times that of Earth. Simply walking or breathing would be impossible for a human. Kepler-277 orbits a G-type main sequence star, similar in size and temperature to our own Sunday. This is significant because Sun-like stars are thought to be among the most stable and life-supporting types of stars in the galaxy. However, Kepler-277b orbits extremely close to its host star, completing one orbit in just 17.3 hours. That's less than a single Earth day. This means the planet is subjected to intense stellar radiation and likely tidally locked, with one side perpetually facing the star and the other in eternal darkness. Surface temperatures on the day side could soar well above 1,500 degrees Celsius 2,732 degrees Fahrenheit, hot enough to melt metals. Any atmosphere it may have once had has likely been stripped away by the star's radiation. Its companion, Kepler-277c, is slightly smaller and orbits farther out, but even it likely shares a similar fate, a super-dense, high-temperature surface bathed in radiation. These conditions make the possibility of Earth-like life seem remote, at least on the surface. But could something exist deeper down? At first glance, Kepler-277b appears utterly inhospitable. The heat, gravity, and radiation levels are beyond anything life on Earth could endure. Surface temperatures alone would vaporize water instantly and prevent the formation of organic molecules as we know them. But when considering extremophiles, organisms on Earth that live in boiling acid, in radioactive waste, or miles underground, the question becomes more nuanced. Could subsurface environments shielded from the star's radiation offer niches for life? If the planet's interior harbors residual heat or volcanic activity, underground reservoirs, insulated from the star's fury, might potentially support primitive life, especially if liquid water or ammonia is present. While purely speculative, this possibility fuels astrobiological interest in extreme exoplanets. Some scientists even theorize that certain megaearths might hold onto thick atmospheres of exotic gases, though Kepler-277b's proximity to its star makes that unlikely without some form of magnetic shielding, and even that would be tenuous. In short, life as we know it is highly unlikely on Kepler-277b. But life as we don't know it, that's where science meets imagination. One of the most intriguing questions about Kepler-277b is how it formed. According to current models of planetary formation, rocky planets typically max out at around 10 Earth masses before they start accreting large gas envelopes and becoming gas giants, like Neptune or Jupiter. Yet Kepler-277b, at 87 Earth masses, has no detectable gas envelope and remains a rocky, high-density world. This challenges traditional models and suggests that either it formed in a gas-poor region of its protoplanetary disk, it lost a massive gas envelope early in its history, or it formed through an unusual series of planetary collisions, gradually building up mass without accumulating significant gas. This planet may represent a new class of supermassive terrestrial worlds, forcing scientists to rethink the boundaries between rocky planets and gas giants. Its mere existence provides valuable data to improve and challenge our understanding of planetary evolution. At present, Kepler-277b is beyond the reach of direct observation. But as new telescopes come online, such as the James Webb Space Telescope, JWST, Plato, and the Extremely Large Telescope, YELT, scientists may be able to study its composition, atmosphere, if any, and orbital behavior in greater detail. Future missions may help determine whether planets like Kepler-277b are common or rare, and whether such megaearths could exist in more temperate zones, farther from their stars, increasing the chances of habitability. As instruments become more sensitive, we may even detect exomoons, rings, or subtle magnetic fields that tell us more about the planet's environment. Ultimately, Kepler-277b is more than an outlier. It's a cosmic puzzle, one that could hold clues to how planets form, how they evolve, and what the boundaries of planetary life might really be. Kepler-277b is not your typical exoplanet. It's an anomaly, a rocky world of staggering mass and density, orbiting dangerously close to a sun-like star. It challenges our theories and stretches our imaginations. While the chance of life on such a hellish planet seems remote, its discovery expands our understanding of what planets can be. It proves that nature often exceeds the limits of our models, forcing science to evolve with every new observation. As we look to the stars in search of Earth-like worlds, we will continue to encounter planets that surprise, defy, and reshape our expectations. And perhaps, in doing so, bring us closer to answering the greatest question of all: are we alone? For now, Kepler-277b remains a giant mystery, a world of extremes orbiting far beyond our reach, yet close enough to teach us something new.